everything is being influenced by code written by developers.
At some point, you're going to wake up and say, what the hell am I doing?
It's hard to believe. It's the largest group I've ever been in front of, I think.
We develop the future.
Hello everyone and welcome to the next edition of We Are Developers Live. Today we are going to talk about Python. We will talk about configuration in Python, pointers in Python, and APIs with Python. But before we start, a couple of short reminders. So first of all, you have seen that our WeAreDevelopers World Congress is back as an in-person event. So we have missed that so much. We have an amazing speaker lineup with, for example, the CEO of GitHub is going to join us with a keynote. The inventor of Angular is going to join us. The co-founder of NPM and many, many others. More than 200 speakers are coming to Berlin to share their knowledge with you. So if you haven't checked it out so far, feel free to do so. worldcongress.dev is the URL. And yeah, happy to welcome you there. And also, as always, feel free to be engaged today with the speakers. Ask your questions in the chat. After each session, we will have a short Q&A with each speaker. And while doing so, please also respect our code of conduct. So here's a short video about that. So, and then basically let's introduce our first speaker. He has been computering since the mid-80s and he fell in love with Python in 2006. Is doing a lot of stuff in the DevOps section, and today he will talk about configuration in Python. So please welcome Oliver.
Hi, nice here.
Hi, how are you doing?
Fine, thanks. Looking forward to the talk. I'm glad glad it's not such a big stage like I just saw in the videos. I like smaller circles of people.
Yeah, we can make it happen, no problem.
Thanks.
Do you want to disclose where you are joining us from?
Yeah, I'm in South Germany, Ravensburg, near Lake Constance, where Avira was headquartered.
Very cool, very cool. And also like the puzzles are coming from there, right?
Exactly, Ravensburger Spiele, yeah.
Perfect.
So everybody knows the game company, but nobody knows the town really. But it's a nice town, nice medieval town.
Very cool. So Oliver, tell us, what are you going to show us today?
Yeah, it's something I did in smaller circles in bar camps, basically talking to other Pythonistas about how to deal with configuration in internal systems. So it's very context sensitive. I mean, configuration is a big word. But you know, it's really like if you build backend systems, systems that need to run in different environments, how do you deal with that in Python so that it's basically for normal programming you don't really have to care about. You just do your thing and the magic happens in the background. So that's why it's called Automagic configuration. And it's not something I came up with, I'm sure, but this is just very Python specific then.
Okay, sounds very interesting, especially if you want to do a bit more with Python than most of people do, I would say. Then I would say, Oliver, the stage is yours. Have fun, and we will see each other in the Q&A.
Okay, thank you. Let me start my timer that I don't lose complete track of time. So, yeah, I guess you can all see my screen. Yeah, Automagic configuration in Python. That's what this is about. And before I start, just very quickly about the structure. There's going to be a beginning, a middle, and an end. And we're going to start at the beginning. And yeah, before I start, let me talk a little bit about my background and my motivation to do something like this. So works great already. I work as a developer for a bit more than a decade now, and I have always worked in very small to small-ish teams, like 3 to 8 people, providing in-house services for other teams. So our customers, I knew them personally, normally. And they were usually developers that are working on the products that shipped. We are responsible for everything needed to be able to ship the code ourselves: design, build, test, deployment, maintenance, on-call service, everything. Nowadays, that's nothing exotic. When I started, at least in the company where I was, it felt a bit exotic. We were a bit the odd ones out in regards to how we organized our own work and everything. And yeah, nowadays it's nothing special anymore, or it's better advertised. I don't know. I always liked working like this because this also came with a great amount of autonomy in the tools and processes we used. Yeah, and we chose Python. And yeah, like an agile approach that we developed ourselves in our team. And that wouldn't be possible without a powerful language like Python and the great community and the great ecosystem that we all use. Yeah, and Avira became Norton last year. We were acquired last year. So I'm doing pretty much the same thing there like I did at Avira, only on a bit larger scale. I also shipped some stuff to customers, so I know what that's like and what's involved there. And, that's a very different way of working, I can say. And, well, I did a few little projects, and I choose to go back to in-house projects again afterwards, because I just like this more. You just have more autonomy then. And what I also like doing, if I find the time and the energy to help in open source developments where I can. I was involved in a few of them over the last years. But I won't go into that much detail. On my website, there's more about this. What's more important for this talk, I think, I attended the first conference in 2011 in Leipzig. It was the first German conference organized by the Python Software Verband. Seeing other developers sharing what they learned and what they're excited about was a very nice experience. And to see how welcoming everybody was and how inclusive the community was, that was just great. So I kept going, and I decided to give my first talk myself a bit later. A talk about how Python really works in 20 minutes. I know, I'm an idiot. When I was preparing for that talk, I realized how little I really know and how short 20 minutes are. But I managed to explain a few things in a way that must have been helpful. Few people approached me afterwards to thank me or discuss something, and I started to feel like I'm really part of a community. Yeah, that was really nice. And some of those people became good friends. And that is also what I'm trying to, whoever is listening, if you have something to say, to share, have a go. Maybe not as the first thing on a big conference and passing in 3 talks and having 2 accepted and then being completely overwhelmed. Maybe better bar camps or smaller meetings, and then work your way up if you want. But yeah, I can really recommend it, because I think the person that learns most usually is yourself when you give the talk. The German society, or it's a club, Verein, it's a non-profit organization, is the pythonverband.org, where you can also become a member and help supporting Python in the German language areas. And the bigger organization, the umbrella organization, is the Python Software Foundation. So that's also on python.org. That's where you end up when you're looking for Python documentation, and you don't end up on one of these search engine optimized pages where the content might be good or not, but sometimes I have the feeling they spend more time being found than producing things that are worth finding. Yeah, but it's a very mixed bag, obviously. But I always, nowadays, I really recommend look at on python.org first before you go anywhere else. Yeah, and the other part of my motivation is when I studied computer science at the University for Applied Sciences, I learned all kinds of stuff, but not really testing in practice. And this is what I was kind of missing when I started out. And also unit test in Python, I wasn't really that happy with it. It felt more like programming Java. So I looked around and found PyTest, and that opened many doors for me in regards to learning more about the language. So if you want to learn really about your language, I think starting off with trying to write tests for the things you write is a very good way. Yeah, I also started to give courses, usually corporate courses, where my experience is usually that Python is used in a lot of places and a lot of people use Python, but you can get very productive with Python very fast without really understanding how it works. And I'm trying to then show a bit more what it looks like under the hood, so to give a bit of a better understanding. Yeah, but what is this about? That's enough about me. Or better, first, what's this not about? It's not about motivating you to write code that is more complicated than it needs to be. So we're going to look at some, maybe also, let's call it dark magic later on if we have enough time, because I will build it up slowly and I will provide the materials. And if we don't get through anything, because this talk was a bit short notice and I wasn't really able to time it completely, but let's see how far we get. Yeah, so it's not about this. It's really about something else. And I would recommend this talk by David Beasley. He just held it last week. Was the coincidence that I saw it. It's a really great talk, like pretty much every talk by David Beasley. The problem with the problem. Yeah, I would just recommend that to watch this if you have some extra time. So what this is also not about is how does this scale, neither performance-wise, nor team size, nor project scope-wise. And to get that out of the way right away, let's look at some code. But first, this type, namespace equals type that you see in the next slide. If you have never seen that before and have no idea what it's good for, that's just a different way of writing class namespace constant equals 1. So setting a class variable. Because this type, usually if you know it, the function, it tells you what type some object has that you pass in, but it also has some more power, which is creating new types. So it's kind of the backbone of creating classes. Yeah. So about performance we were looking at. So if you look at direct name lookup versus attribute lookup. So direct name lookup would be something like this. I set a constant and I assign it and I run this in a repeat and I time it. So this runs, it's now much slower than when I ran it just now. So the StreamYard is kicking in. So if I run this then, so this class that I just showed you before, so if I have one lookup, which is this dot that you see, when you see a dot, you have to think in Python, oh, then something needs to be looked up. Some name needs to be found in some namespace. It's always in some namespace somewhere. And that's just, twice as slow right away. So if it's about performance, things like that don't really play a role in that sense unless you run your code in inner loops and have a lot of lookups there. Then it might actually be worth looking at a profiler to see what steals all the time. It's usually not what you think anyway. So it's not about performance or scale. So why are we here? This is a talk about solving a seemingly boring problem in hopefully several interesting ways. And I might be wrong or correct. I don't judge. I don't know the context in which they might be used. So this is really like every code in any talk you see, it's toy example code. This is mostly about Python as a language. That is one of its core features opens up its internals to make it possible to write libraries and tools that are easy to use on the surface, but hides some very interesting magic to make that possible. Libraries like Attrs, NumPy, PyTest, Ginger2, Django, SQL Alchemy, Pydantic, they are all very interesting to look at on the code side, how they accomplish what they need to do to build such a nice user interface and such a nice functionality. And as a user of those libraries, I write pretty straightforward Python code, maybe using a few decorators or context managers provided by the library here and there. But all in all, it just looks like any other normal Python code. The code we look at here makes use of some of the functionality used to build some more magical code. And you can take the examples here and use them as a lab for your own explorations later on. I will upload, I haven't done yet, also the link is valid, it's still there, it's from my last talks, but I have rewritten a lot. And there's also a lot of bugs in there, I realized when I was preparing this today. So now it's completely bug-free. But that's really not the point. The code will be there for you then to play with it and make your own mind up about if it makes sense or not to do something like this. So what this is really only about is my personal perspective about dealing with configuration in internal backend systems deployed in different scenarios. It bases on the idea that those things should be done in a way that they're safe and easy to use and therefore fade into the background when programming the business logic of the system, whatever that may be, internal built bespoke CI system or a framework to support the development, test, and deployment of machine learning pipelines. It doesn't really matter. And then maybe thinking about words. I also had a short stint as a translator a while back and learned how important it is to agree on shared common terminology. So what do words like configuration and constants mean in practical sense when the scope is limited? Like I said, coming from that limited view, some interesting fundamental features of the Python programming language and how they could be used to deal with configuration and constants in that context. But might be interesting just like that. And you might see a different perspective of the boring topic of configuration and maybe think about what that could mean. Maybe writing a little bit of clever code to support the 98% of the code that doesn't have to worry about these things then. Maybe you learn something new about the Python language and maybe start experimenting a bit more than you might have done until now, because normally you just write Python code that works and is bug-free on the first try, right? And you might leave with some questions and ideas you might find useful in the future to think about your own approach to configuration in different contexts. And it's going to get a bit more code heavy later on, but I think it's really important to look at some terminology first, at least 2 words, because they have meanings for different people, different meanings usually. So if you hear Automagic, that comes from the jargon file, or the jargon file is describing it automatically, but in a way that for some reason, typically because it is too complicated or too ugly or perhaps even too trivial, speaker doesn't feel like explaining to you. I will try explaining to you though, but that's where the word comes from. And where it actually comes from is this product, where there's even a little video, the Automagic Glad Iron, which was this contraption. Looks not very magic in action. It was this automatic shirt pressing machine, Automagic, sorry. So that's one word cleared up, and the other word is configuration, and configuration is such an overloaded term in so many contexts that it kind of has lost all meaning if you don't explain what you actually mean. So, and it's used in different contexts: software configuration management, software configuration management system, and so on. So let's use the Pippi Langstrumpf approach to terminology and just define it ourselves. I don't know the other languages of this song. If you know Pippi Langstrumpf or Pippi Longstocking, the other songs, they don't have that content, but the German content is really about redefining maths and saying that, you know, I define the world like I see fit. So that's what we're going to do now with configuration. Or better, what configuration is not first, because that might be easier. So configuration is not a variable value, something that changes and has very limited scope. It's not user input, maybe. Well, that happens during the process while you're running the software, maybe later on via a GUI or some other form of interaction, or as input value, but maybe that is configuration. I would say maybe it is. Let's see. And it's not a constant. And what is a constant? I mean, there are not that many real constants. I mean, in preparation for this talk, I also looked up about physical constants, because I think they must be really stable, but no, they get updated every few years. And the NIST is providing updates for their constants. So the only constants you're left over then maybe are mathematical constants. But otherwise, everything is pretty much variable, at least between runs. So what is configuration then? What is left over in the end? So, and the more you think about these terms and their definitions in the general sense, you might find the more the lines are starting to blur, especially when you throw configuration into the mix. And there's Alan J. Perlis. He wrote, I think, 99 or something, 100 programming epigrams. And the first one is one man's constant is another man's variable. And I think I start to understand what he meant. Could also think one person's configuration is another person's constant. And what also might be worth thinking about, what is primary and what is derived? So what is really something I'm basing everything on? And one example would be, let me just start fresh. A little file that is setting the project root. You know, that might be some code that you see maybe in the module. This is the context, the source code of a module. It doesn't do much. It just sets a project root path somewhere in relation to where this defining file is. Prints it out. So this is actually here my presentation folder. And then I can find the image path from there. So from that point on, when I have that set, then I have an anchor that I can define everything based on. And I don't have to worry about it anymore later in the code. I just always access the project root, and then I can access the files there. So that's one typical example of maybe what is kind of a constant or kind of a configuration. So this is a constant defined where the project root is, and then there's the derived data that you build up on then other folders, and that might be other constants then maybe that base on that project root folder. So that is what configuration might be. Now let's move from, you look at what classic configuration might be seen in programs and move to Automagic configuration. So classic configuration is great, yes, in the right context. So when the location where configuration needs to be stored can be part of the code repository, when otherwise changing a configuration value would lead to a slow build or compilation, when non-developers need to be able to configure your software, maybe then you rather have to provide a GUI or something. Or when developers not speaking Python need to configure your software, but maybe you could teach them Python instead of making them use XML. Just a thought. Classic configuration is not great though, in the wrong context, for example, and that's the context I've been working on almost exclusively over the last decade, if all developers on the project speak Python and none of the above reasons are given, you might not need classic configuration. So just use Python, put the config in your code repo, done. Configuration in Python even works for some widely used open source projects. You know one of them at least as a consumer, because every one of you has been to python.org, I'm pretty sure, and that is being generated with Sphinx, and they have a config.py, which is a Python file where you do your configuration. Works nicely. And there's Plotly, which is a graphing library. They have like a configuration API where you can configure it with Python. And there's Nox, which is an automation tool also for Python testing mainly. They have a Nox file, so you configure your automation with Python and adding a little bit of decorator magic to make this work. And then setup.py itself is executable configuration for distribution package build and installation. So that's still part of the normal way of packaging, although that is slowly changing. Yeah, so like everything, this comes with its own set of problems, of course, but it's nothing exotic. So if you create a system where everybody on the team needs to speak Python, why not use Python for configuration? And while we're at it, if you write an in-house system maintained by a small team of developers, why not integrate the configuration into your system and avoid it as much as possible? And that is where this primary versus derived comes into. So yeah, and we will look at a few things now how to do this with the remaining time. First example I wanted to show you is something completely hypothetical. It's a PyTest plugin called PyTest VW, which does this by gleaning at the environment to find out, okay, I am now running on a CI system. Good. CI systems are there for being green so that I can publish my code. So why not hook myself into the PyTest mechanics and just set every outcome of a test to green if any of these environment variables are found. That is a completely normal thing to do, I guess, for some, or not. It might not be a good idea, but it's possible. That's the link to the hook in PyTest if you want to have a look. But before we can look into that deeper, and I know that is, okay. We have to look at a few basic things first, because otherwise the rest is not really a good idea. So let's see how far we get. So what happens when a Python module is run? I have some code here. One second, I always forget this. I have some Python modules. They're just really boring under init.py modules, and I have one file here that I actually want to run. So the content of all these init.py files, they are just printf, an f string with the file, which comes from the module import system, which is usually there unless you run in Jupyter, for example. So then we will see what gets executed in which order, because everything in Python is an object and everything is executable code. And there is no such thing as compile time and runtime in Python. It's interleaved. So code is executed as soon as a module is imported. And you can import modules later on in the process, and then you have another parse, compile, runtime cycle there. So this is what the main file looks like. There's a few little functions in there. That's the main function where it's all about. So that's like the business logic, the speak functions. Then there's an entry point function, and then this if name equals main. I mean, that's quite seen very often, but it's just a normal if statement. So you can also do an else and say, is this run as a script or is this run as a module? That's all. And if we run this like this as a direct import, then we see all these modules are imported and the code in there is executed and it gets printed. And then here you can see, okay, the module is imported, and then you can see the actual functionality. And if we do this in different ways, for example, run this on the command line with the -m, so run this from the command line as a module, see the same thing, but this time it's run as a script, because now the entry point is main, because it's run as a script and not as an import. And if I run this like this, so like a normal Python script, I run this script directly. I just want to run this script. That's all I want. So why not just do this? But the difference is that here you completely circumvent everything that is around it. So you kind of circumvent the import mechanics there, because you just run it as a normal Python script, and it doesn't really know, if it doesn't do any imports there, it doesn't really know that it's part of some deep package system. So that's an important difference that you need to be aware about when you do anything in regards to these things. And it's also run as a script, but yeah, it doesn't look like this. Okay. And then you saw the entry point function. That's also the name of the function doesn't matter. It's just the function that I define there. And then I can create a setup py where I say, oh, by the way, this function in here is now my command line tool Alice in Wonderland, and I install this in a virtual environment. Then a binary gets created, and on Linux it looks like this. In Windows, it's actually a .exe file that you can't really look into, but in Linux, it's just a wrapper that tells the script where actually my virtual environment is, and then loads the entry point and runs it. And the main difference to running it as a normal script is also that this whole import mechanics that you have seen before is also again in action, because in the end, the module is imported to the entry point. So these are the different ways how you can run Python and how the code travels through till it finds your entry point in different scenarios. If you want to know more about this, the execution model in the python.org docs are really good. And it's a very short document, actually. It's a quick read. Setup py, and I said already, setup py might be on the way out in the long run. And if you want to know more about that and how one maybe does installable Python packages nowadays better, look at this nice blog post from Bernard Gabor. Did that quite a while ago. He's very active in that area to improve packaging. So in general, he knows what he's talking about in regards to these things. So that's a good article to read. And what I like to think about when I look at all these examples, I know it's a stupid comparison, but I like to make stupid comparisons. In the Big Bang Theory, the fleeting period between the Big Bang itself and the so-called Planck time, when the universe was 10 to the negative power of 43 seconds old, and the temperature was 1034 Kelvin, in this period, quantum gravitational effects are thought to have dominated. Theoretical understanding of this phase is virtually non-existent. So if you compare this to the Python startup, and why shouldn't you? Everything before reaching your intended entry point, whatever that is, we have seen a few, and how you can get at different places in the code just by how you import the code, run the code, install the code. Everything before your entry point is kind of this Planck era of your process where things happen, code gets executed, but you're actually not in the function that you just wanted to run. So that's one important detail. And now let's add Jupyter and code cells running in a pseudo module quickly. So this is an old run. Now let's restart the kernel. So if I run a Jupyter cell here, there's not really much in there. But here it says automatically created module for IPython interactive environment. And it doesn't have a dunder file attribute because it's like a pseudo module. But you can think about this when you see all this code here. You can think about it like a module, pretty much, especially what I'm showing you. So if we have this in mind and do look into what's happening in regards to names now. So now we looked at import time, what happens there. Now we need to know about names and objects quickly. So if I create a class object and I create a class object again, I can only have one. So I see here it has a different memory address than that, and that is actually my name. So this has been created and has been destroyed right away. The reference counting garbage collection has picked it up, I guess. And now we have this. So we have the name, a class that points to this object. And I explained this super quickly, and Eli hopefully will explain this much better if you haven't really ever seen this. But if you have no clue whatsoever about this, at least know this now. So, and if I source something from a module called a class, which doesn't really do much, but just defines the same thing again, I have a different memory address. And if I now ask for what my class is, so the ID, the memory address of the class, this is now ends with a 16. If I execute this code again now, ends with a 104, like this. So there's only one name that points to one object. And I only have one given namespace. But if it's not found in my current namespace, there are lookup methods then to find names in other namespaces. Yeah, so that was that. Are we getting a bit closer? So let's look at some constants versus configuration. So this is a classic constant. Days in the week is 7. This is, am I running on Windows or not? So I'm inspecting already the underlying system. So is this a constant or is this configuration? Because if I run the same code on a different system, there might be a different value. So this might actually be part of the configuration rather than a normal constant. Or if I get something from the environment, there it's much more obvious even. This might change, but I still set this as a constant. And you see this kind of code very often, also on the module level of code. So these are, to all intents and purposes, constants. What if we look a bit more? Yeah, it's just... Let's start fresh. So if I look what the version is, I can see is the system too old or not? Is it smaller than 3? Or I can even check for new language features. I have a little module here that has structure pattern matching, which is new in 3.10. So I can try to import this, and I can catch the syntax error, and then set my constant according to this. So this is Python 3.8, so I don't have pattern matching. So that's not the case here. So that's also, what is that? Constant configuration. That's the contents of that module, and that match point, that is 3.10 syntax, and that crashes wherever else you call this. But you could write code like this. Yeah, so what are simple constants? What is configuration? All of the things we call constants, I deem configuration based on operating system, runtime version, whatever. So the lines are kind of starting to blur, and that is really exactly where I'm trying to get at. And a value initialized during program start by gathering information from the user or the system, which might determine different paths, is for me part of the configuration. So everything but days in the week is configuration. And during the runtime of the program, these values should not change anymore. So they should be treated like constants as soon as they're initialized. And should, is being the operative word here. So can we change those constants? Let's look at a few things that very much look like, internal things that you better don't change. So the documentation of the logging module, for example. Can I change that? Turns out I can. The logging module, if you look at it, if you go to the source code, it's just a normal Python module, and it behaves like every other module. So it behaves like your own modules. So you can also set the doc string on your own. So, and this special attribute might be special, but not special enough to be write protected. Let's try something else. Executable and version. I mean, this should be clearly some wholly untouchable constants, right? Doesn't look like it. So constants, configuration. I mean, they're written, the convention in Python anyway, constants should be written in all uppercase, snake case. They're written small, so they're not constant. But I mean, can I change my operating system by just changing the value? Not really. At least I can't delete them, right? Okay. Looks like I can. So I just successfully deleted the version of my Python. And the code in here that I just imported is really just as imports this version. And the one that changes the system is just setting it. There's no extra magic necessary. You can cause all kinds of havoc if you want to. And that's usually what horrifies then people who come from C, C++, Java, compiled languages. But apparently you still are able to be productive with Python. So that might not be a problem after all. Is everything in Python mutable? Let's try looking at the root. So what's the root of the logging object? There's a method called MRO, method resolution order, although it might be better called name resolution order because it finds all names, not just methods. And it shows you where it will look for names if it doesn't find them on your own object. So here, if I don't find doc on logging, it would be found on object. But MRO return a types method resolution order. If I look at the MRO of the 1, it's int inheriting from object. If I look at true, it's also inheriting from int. True, it has actually the numerical value 1. But it's also, in the end, you end up with object. And if you look at something more complicated, like the null handler, you go up some chain, but you end up with object. So object seems to be the root of everything. Let's create one of those. And look at the docstring, base class of the class hierarchy. When called, it accepts no arguments, blah, blah, blah. Okay, let's override that. That doesn't work. So that was a bit faster. Attribute error. Object attribute doc is read only. So there is some mechanism to control write access to attributes. And are they available for writing your own code? We'll see. So object doc is the attribute attached to the object class, which is immutable. Logging doc is an attribute on the logging module instance, behaves like any other normal attribute on an instance, and is therefore mutable. Okay, what about dictionaries? Dictionaries are basically what's behind namespaces, and they are a honking great idea, according to the Zen. So why not putting all configuration in dictionaries and be done with it? Let's ask, what about if I, instead of writing code like this, I'm still on the Commodore 64, you could just write this. It's perfectly valid Python code, and I'm accessing the dictionaries that are under the hood directly, but I don't think anybody would want to write code like this because readability, static analysis, and code completion will suffer. So now we have a few minutes left where we can actually look at that main code. But really, the most important things I wanted to say are said, and this is kind of now you're set to look yourself at the example code, which might look a bit daunting. This is why it's completely unrealistic, really, to go through it in detail. But they are trying to accomplish the same thing in different ways. So we start with a module level constant. We then have a namespace class that does the same thing, and we always have some function that does something in independency of what kind of system am I running on? Like, am I running on CI or not? Am I running in the cloud? And they all do the same thing, only with different. And in, let's say, in growing order of magicness, although I might even swap this and this, so D and E, I would even put E in front of this. And there are all tests for it. So if you download the code and you install the package with PyTest, you can run the tests yourself and play around with it. And that is really the main thing why I'm doing this, because going through this in detail in the talk like this is kind of unrealistic anyway, which I realized when I was preparing for this talk with a different kind of audience. But let's have a look at the one. I mean, I'm skipping over the simple thing. I want to show at least you the one that basically is the one that I have found to be the kind of the sweet spot with all between all the magic and you know, being kind of safe and making things easy to use and easy to test, and that is C. Singleton instance with read-only properties. And the magic there is also not that horrible. I just show you the quick succession here. For example, for the system, which determines its own platform, it sets a platform name, and then it checks out, okay, am I on CI? Am I on cloud? Am I in a dev box? Really like a very common thing to do for internal systems, where you, in some cases, always need to know where you are. Life is messy. It's usually not a good idea to write a system that is completely unaware on all levels, because that might make things extremely cumbersome to work with. So you need to find some kind of compromise. So that would be the naive approach. And the advantages and disadvantages to test them, they are shown in app import directly and app import module. And when you run the test, you will see that and you can play with it. And then one step up might be like a namespace class, where you put this in a class object, and you have at least an extra namespace around the module, and you can wrap up your code together with the data. And the thing that has been working best for me is this approach, which looks horribly wrong, I guess, on first look, because method names should be lowercase, snake case. But if you think about it, if you write your code like what you're intending, what this is intending, this is actually a constant, looks like a constant, it behaves like a constant, and it's really with a slight detail that this is dynamically executed code. So if you don't know what a property is yet, that might be helpful to look up then. So this is then executed code. And whenever somebody accesses it, and there's a singleton instance here, so you only have one instance of this. It's not enforced or anything, but it's just that's the one that everybody uses. And then you have access to these constants, and they are constant throughout your run. And in production, this will never ever be touched. But if you're testing your code, then you have the possibility to actually change things around a bit and then test your system in a way that you can say, okay, what about if I want to I want to see how it behaves if it runs on CI or on DevBox or whatever. Then you can write very simple tests, parameterized tests here in PyTest, that simulate different system setups and just test them. And if you run this code, if you run the modules directly also, you will also see what happens. You will always see what happens. So if I run this constants module, I see here that it gets set up, what gets set. And those tests, they will guide you through and to get an idea what are the advantages and disadvantages of the different approaches. And if there are problems or errors or whatever, please let me know, because I'm also doing this really to, to hear from others who dealt with different problems. And I realize I'm running out of time, so. But I think that hopefully was a feasible introduction to the topic. And if you're really interested in this, if you're really into this, you will look at the code, you will play at the code. And if not, then maybe you at least heard some ideas about how to think about what configs and constants and all these terms might mean actually in your context, and think about this in your contexts. Yeah, and with that, I would say Thank you very much. And the materials will be here. So, and they are online already, like I said, but it's an old version from last year, and I will upload the new materials, I think, during the day today, because they're basically ready. Just have to tidy them up a bit. Yeah, and then you can play with it. And if you want to get in touch, maybe connect with me on Twitter, write me a message, whatever you like. And now my 45 minutes are over. Thank you very much,
Oliver. Thank you very much. Awesome with the timer. Or did you just hit it when you finished the presentation? When you went
yeah,
to the
sure.
last
I was
slide?
faking it.
Perfect. Thanks. A very nice introduction, very nice presentation style. And people, I think, like your mouse pointer.
Yeah, it's the Hand of Evil from Dungeon Keeper, I think the game was called.
It's really great. So let me see, as we are running a bit out of time, but let me see, like we have a couple of questions. Ines is asking, how do you do version handling?
Well, that's one of the nice things if you're working in a small internal team that has all their code base under control. I mean, internal version handling, yeah. There's dependency version handling, and then there's your internal versions. We actually switched to a monorepo last year. We had different packages. We had real Python packages for a while, but we realized at some point this is just making our life more complex because the way we're deploying them, we don't need Python packages. We just deploy code. And the code moves in one direction, and that direction is forward, and it moves together. Because if I change something, or any of my colleagues changes something, they fix a bug. They fix a bug in the library, and they fix it in all consumers of that function. And that is one code stage, and that will be committed, tested, deployed. So life is very simple like that.
And you never look back.
Complicated enough. Sorry?
And you never look back.
Exactly. Moving forward is the only way.
Okay, then Peter has an interesting question regarding constants versus configuration. Should configure? I think it was meant like, shouldn't configuration change as well during runtime? I think on that slide you said something like constant shouldn't change, right? Because there are constants.
Sorry. That's a very good question, though, because that's where it starts to get blurry. And you know, as a general question, this question is unanswerable because it really depends on the context. But you know, if for me, configuration is something that gets initialized at startup in that way that I showed, you know, a little bit at least in the end, which means in this Plunk era of the process where the system initializes itself, it sets everything up. And in the moment when you end up in your entry point, when you start to execute code, the whole universe is shaped in the right way. You know which operating system you're running on. You know all the primary and derived constants, so to say, and then you just write your code. And that never changes during runtime. That's for me is that kind of configuration. And then for tests, you can fiddle with that. You can say, okay, now I fake in a very simple way then, because it's simple to fake with monkey patching, for example. I'm running on CI, and then I'm seeing what's happening.
Okay, thank you. Let's take one more question. Maybe first a very quick one, like what was your first computer? Question from Martin.
Commodore 64. I thought that hint, that's why I called this my... I had the old bread box, not the nice, the second generation, the C128.
Nice. And then last question for this session: what are some common mistakes with your approach that one should avoid? A question by Leo.
Yeah, and they are really, I try to point them out in the code and the tests. For example, what can go wrong if you have module level configuration? There are two different named up. Can you still see my screen?
We can put it on.
There are two different up import directly and up import module. And then there are different tests for that that actually show the problems that you have with that and why this super simple approach might not be a good idea in some context. And then descriptors are really kind of here be Dragon's area for many, many reasons. But descriptors are the mechanics behind how properties are actually implemented. And it's definitely interesting to look at and play with it. But yeah, the dangers are also context sensitive. So also depends on what kind of code you have, where it runs, and what the context is. But I try to cover a lot of possible problems in the example code.
Okay, perfect. And then, Oliver, thank you so much for joining us. I think best way to get in touch with you is over Twitter. So make sure you follow him. Awesome session. Thanks for the nice overview. And I hope to see you soon again at maybe some other event, Live Day, World Congress, whatever.
Yeah. Thanks, yeah.
Really
And
nice.
and thank you again for inviting me and for
You
your
are very
generous
welcome.
donation to the Python Software Foundation. I wanted to
Yeah,
make
you're
this
very welcome. Thank you so much, Oliver. And have a nice day
You
in
too.
Ravensburg. And yeah, bye-bye.
Bye to Vienna.
So let's jump into a very quick break, like just a couple of minutes, and then we are going to start with our next session. So see you in a couple of minutes. Hi everyone and welcome back to our next session, and please welcome Eli on stage. Hi, how are you doing?
I am well, thank you.
You want to disclose where are you joining us from?
I'm joining from Cambridge in England, where we're having some pretty abysmal weather, just miserable.
Okay, so very British. So I've learned a bit about you. So I learned that you have a cat and that you basically have to save your houseplants from her. I can relate to
Yes.
that. Same here at
Yes.
home.
Yeah,
Very
no, I have
funny.
a spider plant that she absolutely demolished one time. So,
Oh,
and this is a
okay,
very
okay.
important fact about me. So I'm glad that you've managed to find this out.
Yeah. No, I mean, we have solved it by just removing all the plants, unfortunately. Like we have one or two somewhere on the top where you can't reach it, but kind of they manage somehow to do it. Eli, first of all, thank you so much for joining us today and for taking the time. Do you want to give us a short sneak preview about what we are going to learn from you today?
Yeah, so my talk is kind of a whistle-stop tour of memory management in Python, and in the later section focusing specifically on CPython and its garbage collection. And it's sort of aimed at, I mean, anybody who is interested in how Python handles objects in memory, but particularly aimed at sort of explaining some unintuitive behaviors you may have seen from it. So particularly if you're a beginner and you're sort of, this is stuff that you don't know, this talk is aimed to be accessible to you.
Okay, perfect. That sounds very interesting. So I would say have a lot of fun, and we will see each other in the Q&A session afterwards.
All right. Yes. Welcome, everybody. My name is Eli. I'm a developer advocate at Anvil, which is the platform for building full-stack web apps with nothing but Python. And today I'm going to be talking to you about pointers in my Python. This talk has 3 sections. We're going to be talking about what pointers are and where you'll see them in your code. We're going to be talking about what the ID of a Python object is and why it matters. And finally, we'll cover how CPython in particular can tell when you're done using an object that it has in memory and what happens next. So, what is a pointer? Well, a pointer points at something, which is not necessarily a particularly helpful explanation. So let's see some examples. Here is me, and I have a name, Eli. That name points at me, it refers to me. But it's not the only way that you can refer to me. Unfortunately, I am on Twitter, and I have a Twitter handle, and that points at me. I also have a Hebrew name, and there are many other ways that you might want to point at me. So these are kind of a sort of an analogy of what pointers are. And in Python, pointers are names that correspond to objects. So objects in the namespace, and the namespace is anything you could type into a Python interpreter and Python would understand what you meant by it. And then, so they're objects in that namespace that correspond to objects in memory. So the name of your variable is a pointer, and the actual thing it points to, the thing it refers to, is the object in memory. So Python lists in Python contain pointers, and for that reason, we're going to be using them as for a lot of examples throughout this talk. So here we've got a sort of visual representation of a list, and around the outside you have the list object, and this has all of the things that you would expect from a list, like being able to append to it, being able to get items from it by index, and then it also has pointers to all the things that are in that list, all of the contents. So if you've got this list A and it has 2 elements, a string and a mutable object, there within that list object, there are pointers to its contents. And this structure makes them very useful for demonstrating a lot of the behaviors that pointers give rise to in Python. So we're going to talk about pointer aliasing, which is a behavior that can come up, especially when you're quite new to Python, where you change one variable and another thing that you didn't intend to change has changed. And the reason that this happens is because of pointers. So we're going to use an example here where we've got a list, and it's just a list of strings. It's my cool list. And we've defined it, and we've got the interpreter to print it back out to us. Then let's say we want to make a copy of this. So we'll set B is equal to A. We're making a new thing, B, and we're saying that should be equal to A. And we want to make B be my awesome list instead of my cool list. So we simply change the second element of that list to awesome. And we get the interpreter to print that back out to us, and then we see that B is now my awesome list. However, if we look at A, we see that we changed A as well. This is pointer aliasing. This is when we have 2 pointers to the same object. Because what happened when we set B is equal to A, we created a new thing, B, in the namespace, but it pointed to the same object in memory that A does. And that's why when we change B, we're also changing A. So what if we didn't want this behavior? If we wanted to really make a new copy and change it without changing the original? Well, lists have a method called copy that we can call. And we can see this in action where we say if we've got C and we want to make that be a new copy of A, and we want this to be my amazing list instead of my awesome list. We define it, we print it out, get the interpreter to print it out for us. And if we look at A, we can see that A hasn't changed. And this is great, right? So this is how you can make a new copy of the list object so that you can modify it without modifying the original. However, if we think about that original representation of a list, the list object wasn't the only thing that we had there. We also had within the list objects pointers to its contents. And in this case, the contents are strings. And so they're not mutable. So when we change them, we just replace them. But if the contents of our list were mutable, then copy wouldn't be enough. And we'll see an example of this. What if we had pointers inside our pointers? So here we're defining a list that it has one element, and that element is itself a list. So we have an outer list and an inner list. And our inner list is just Alex and Beth. So again, we've defined it. We're getting the interpreter to print it back out to us. Now, let's make a copy as we did in the second half of the previous example. And we want to amend, we want to change that inner list, right? And to do that, we get that inner list with B0, the first index, the first item in that list, and we append Charlie to it. And if we print out that list, we can see that that's happened. And again, if we print out A0, the first element of our original list, that's also changed. And this is because copy makes a new version of that outer list object, but all of its contents are still the same. All of the pointers just point to the same contents. So what happens if you had a list within a list within a list within a list, and you wanted to make an entirely new copy? What if you wanted to have, you wanted to make a completely new structure with no pointer aliasing at all? Well, there is a method called deep copy from the copy module in the standard library, and you can just import this and call it. And so we're going to do that on our list within a list, A. We're going to make C, and then we're going to do exactly the same thing again. We're going to append something to that inner list. We're going to append Dan, and we can see here that that's happened. But when we go back to look at our original list, the inner list of that original list, that hasn't been appended. And this is because deep copy made an entirely new version of the inner list as well as the outer list. And this is true no matter how many layers of recursion of pointers that you have. So let's see some visual examples of this. So this is what we did the first time. We set B is equals to A, and equals just makes a new pointer to the same object in memory. So you've got this white box refers to the outer object, and the orange is like the contents. And you can see here that when you set B is equal to A, it's not actually making any new objects. It's just making a new pointer. But if we use copy, we can see that it makes a new object, the new outer sort of infrastructure of the list, but it still points to the same contents that the original pointed to. So that's what happens when you use the list copy method. And finally, deep copy makes a new object and new values for that object to point to all the way down. So I've added this blue bar in the middle here to show that they're completely disjoint. There's no pointer aliasing between these two things. They're completely separate. And there are different times when you might want various of these behaviors, and therefore you would choose various of these methods. So that's pointer aliasing. So we've looked at lists which are mutable and they contain pointers. So what happens if we look at an immutable object? So tuples are basically immutable versions of lists. Once they're created, the things that their elements are frozen in place. You can't change them afterwards. You can't assign to an element within a tuple. But while the tuple itself is immutable, the things that they point to, their elements point to, don't have to be. So we're going to look at a tuple that has mutable contents. Sorry. So we've made ourselves a little tuple, and you can see the brackets around it that in orange are round brackets, just to be extra clear that this is a tuple and not a list. And it has one element, and that element is a list. We're just printing that out, get the interpreter to print that back out to us. So this is just a list, and we can just append to it. So we can see that happening. We've appended 4 to the end of this list, and all is well and good. There's another way that we could do this exact same action, and that is with the plus equals operator. But when we try and do that, we get an error. And that's because the plus equals operator is trying to assign to the value of A0. And the error that we get here is exactly what you expect. Tuple object does not support item assignment. That's completely reasonable. We can't assign to tuples. That's kind of what they are. However, if we now print out the value of that first element of the tuple, A0, you can see that 5 was appended. So this is really weird behavior, right? We tried to do something, it threw an error, but it still did the thing that we wanted it to do. And this is because of the behavior of the plus equals modifier. It first mutates the list in place and then assigns the pointer that did point at that old list to the new list. And it's this sort of particularly unintuitive behavior when it comes to mutable objects. But the reason that this happens is because the plus equals modifier also needs to be able to handle immutable objects such as strings. And you can go and look at the behavior of this operator in the Python docs. It's really interesting. But anyway, because of the way that Python handles memory, you get this weird situation happening where it gives you an error, but then did the thing anyway. So tuples behaving badly. When we talked about tuples, we were talking about, I'm sorry. Right. So with that said, we've got these situations where we've got all these different objects and they're pointing at various things, and whether or not they're the same object matters, right? I want to know if B is the same as A so that to know if I will end up with pointer aliasing. And object IDs are the way that we can tell whether objects are the same. The ID built-in exists in Python, and you can call it on an object. And what this ID built-in will give you when you call on an object is a number, an integer to be precise, that is unique for that object. It is constant as long as X remains in memory, which is what we call the lifetime of X. As long as that object is in Python's memory, you can call this ID function on it and you'll get the same unique number. So many Python implementations use the object's memory address as its ID, but that's not true of all Python implementations. So the address in memory is a really good option to choose for using as the ID because it has to be unique. Only one object can live at the same memory address. It has to be constant over the lifetime of X, because if it moves, then you've created a different object and it's not the same object. And obviously, once X is out of memory and that memory is freed, the memory address no longer points at it, so it's totally fine. However, again, not all Python implementations use this because not all of them have access to memory addresses. So CPython does, and CPython, which we'll be looking at later in this talk, does use the memory address. But Sculpt, which is a Python to JavaScript compiler, which we use pretty heavily in Anvil in order to have Python work in the browser, generates and caches a random number and attaches that number to the object X, and that number just lives with that object for its lifetime. So we're going to use examples from CPython for the rest of this talk, just for familiarity, because that's what a lot of people use. And let's look at some IDs. So we've got our example of a list again. I've just got my list with some strings in it, and I'm calling the ID built-in on it, and it gives me this big long number. If you do code in C at all, you might be more familiar with this number if it was written in hexadecimal, because it is just the value of a pointer. So, big long number. And if we do the thing that we did before and we set B equal to A, we're creating a new pointer to the same list object, and we call the ID built-ins on both of these pointers, we can see that they have the same value. And this corresponds to the fact that they point to the same object in memory. So A and B are the same, they have the same ID. Whereas if we do the copy method, we make a new list object, we can see that when we call the ID built-in on these two objects, on these two pointers, they have different values. They point at different list objects in memory, which is exactly corresponding to what we saw before. So this raises the question of when two objects are actually the same, because obviously we have this idea of their IDs and we can compare their IDs. But when we copied A with A copy, the thing that we got out, C, it's kind of the same, right? It's just a copy of the thing. Like sometimes you might want to consider those to be equivalent, right? And Python lets you do this. So let's set up this same situation where we've got a list A, and we've got B, which is another pointer to that same list object, and then we've got C, which is a new copy of that list object. And let's look at some truth conditions on these three objects. We've got A is equal to B with this double equals operator, comparator. That's true. And we've got A is B, and that's also true. And then when we look at the same truth conditions when applied to A and C, we can see that A is equal to C is true, but A is C is false. So clearly these two truth conditions are not doing the same thing. And the difference between them is the is operator, comparator, uses the built-in ID. Saying that A is B is directly equivalent to saying that their IDs are the same number. And so this is basically is saying, are these two objects the same literal object in memory? So that's what is does. What does the double equals of comparator do? Well, it uses this magic method equals. And you might be familiar with some other magic methods. So what is it? Magic methods are things that you can define on classes, and they've got double underscores to indicate that they typically deal with some sort of built-in behaviors of Python. And some other ones you might be familiar with are the str built-in, which defines a class, the behavior of an object when the str built-in in Python is called on it. We've got the magic del method, which we'll see later in this talk. And of course, init, which defines the behavior of class when you first instantiate it. So the magic equals method defines the behavior of a class when the double equals comparator is applied to instances of that class. And we're going to see that in action now. I've defined a class, and the magic equals method is just a method. So we can just define it on a class. And here what I've done is I've set it to just fall through to that other truth condition, the is comparator that just directly compares the IDs of two objects. And this is actually the default behavior of user-defined classes in Python. So by writing this definition out, I haven't really done anything except make it very explicit. But of course, we could do something else. So here's another class definition. And this is my named class. When it's instantiated, we give it a name just so that we can tell instances apart quite easily. And I have set its equals operator to just indiscriminately return true. Two instances of this class will always compare true to each other. And this can lead to some unusual behavior that you might think is incorrect, because with this class, we can define two instances that have different names. And so we've got A is an instance of this with the name A, and B is an instance with the name B because I'm unimaginative. Obviously, their names aren't the same because one is A and one is B. But if we compare the classes themselves directly, it compares true. We think that A is equal to B, and that's because it's calling this equals method here that just always returns true no matter what. And so we end up with this behavior. Of course, you could go the other way. You could set something to always return false. So my unique class, and you might think that this is sensible, right? Like two different instances of this class will never spuriously compare true to each other. You know, you've got A and B, and they aren't the same. But you then end up with this behavior, which is that A is not equals to itself. Because even when you're comparing an object to itself, it's still calling that magic method, and we set that to indiscriminately return false. So the lesson here is that magic methods are scary and you should mess with them at your peril. Right. So earlier when we mentioned the object ID, we defined it. We said that it's unique and constant for the lifetime of X. And the lifetime of X is the span of time that the object X remains in Python's memory. And what that actually means is, what that actually means is that the object lives in Python's memory for a certain amount of time, and then at a certain point, Python will decide you don't need that anymore, and it frees the memory, and that object is gone. So how does Python free memory? It frees memory in two ways. And the first is by reference counting. And this will be pretty easy for us to understand at this point because references are pointers. If something points at an object, it's a reference to that object. And actually in other languages, such as C++, what we've been calling pointers in this talk is very similar to references in C++. However, there are times when reference counting isn't enough. Well, okay, how reference counting works, Python keeps track of how many things point at a given object. How many names does a certain thing have? Because if something points at an object from the namespace, it means you, as the person writing code, can access that object. If there is nothing left in your namespace that can access a given object, if its reference count is 0, that means that object is unreachable from the namespace. It's useless. You can't possibly get at it anymore. So Python is safe to remove it from memory. So what Python does is it keeps track of how many references every object has. And if it falls to 0, it goes, don't need that anymore. That's gone. However, this isn't always sufficient. And for the circumstances where this isn't sufficient, which we will see later, there is something called the garbage collector. And this is something that exists, I think, in every Python implementation. We will be looking specifically at CPython's garbage collection implementation. But first, let's look at some reference counting. And in order to see what happens when an object is removed from memory, we will be using the magic del method. This is a method that is called on an object when it is about to be removed from memory. It doesn't actually handle the freeing of the memory. If there's something that, like, let's say that when you instantiated an object, an instance of your class, you opened a file and you need to make sure that that file then gets closed before you delete that, before that object stops existing anymore. It's like a tidy up method. And we're going to be using it by defining our own class. And all we're doing in this magic del method here is printing something to let us know that the object's about to be removed, to give us a little bit of extra visibility. So in this class, again, we're giving it a name so we can keep track of our instances. And when an instance of this class is about to be removed from memory by Python, whether that's through reference counting or garbage collection, we're just going to make it print us something out to standard output, just so we can see that that deletion is about to happen. So let's see it in action. I'm going to create Dave, and Dave is an instance of this named class. And Dave with a small d is a pointer to this object in memory. We can remove pointers from the namespace by calling del on them. And if we do that, the object in memory, this named class instance, its reference count falls to 0 and Python gets rid of it. And we can see that happen because the magic del method was called and it printed us out that little Dave is being deleted message. So what happens if you have more than one reference to an object? Well, it's very easy to set that up. We can have Alice, who is another instance of my named class, and we can create a second pointer to Alice in exactly the same way as we did with our lists by just saying, I want another variable, also Alice, and I'm going to set it equals to Alice. So now we have 2 pointers to this same object. And if we delete one, we say del Alice, the first one, nothing happens. We don't get that print statement in our standard output. We'll have to delete the other pointer too. And when we do, we see that the object is removed from memory. We created 2 references to it. We got rid of both of them. Its reference count is 0 and it's been removed from memory. However, I mentioned that reference counting is not enough. And the way that can happen is with cyclic references. So if you can actually set up a cycle of 1, an object can refer to itself. We're going to set up a system where we've got 2 objects and each of them points at each other. And we can see this. Oh, okay. In order to do this, we're going to need to have a look at what pointers are available to us. So pointers, again, being objects in the namespace that refer to objects in memory. And we can look at the namespace by calling this globals built in. If we call this, it prints us out this big long dictionary, right, of various things that you have. And these are all things that if you typed them into the Python interpreter, Python would know what you meant. And a lot of them we don't have to care about. But in our situation, right at the end, you would see this my named class referring to a class definition. And that is because if I type in my named class, Python knows what that is. And that's the class that I defined that has this magic del method that we've written. And so this is a way that we can have a look and see what pointers we have available. And the way we're going to do this typically is by just looking for whether or not a particular thing is in the namespace. And the way you do that is you say, is this in globals? And it'll tell you true or false. So with my name class and globals, we can say, hey, does this class definition exist? And it does. So what we're going to do is we're going to set up 2 instances of that named class. The 2 objects in memory of that named class type. And these are just arbitrary Python objects, which means we can just set arbitrary attributes on them. So I'm going to set Jane and Bob to be friends with each other. Bob friend is Jane and Jane friend is Bob. So now we have two objects and they both have pointers to each other. And if we look to see if these pointers are in the namespace, these names of these objects that we've given, Jane is in globals and Bob is in globals. That means we still have pointers from the namespace to both of these objects. But if we delete those pointers, you might expect that, well, their reference count should have fallen to 0. We can't access them from the namespace anymore, right? Why aren't we getting that print statement that tells us that Jane is being deleted and Bob is being deleted? And, you know, even though neither of those pointers are now in the namespace, their reference count of these objects is not 0 because they pointed at each other. The object known as Bob, previously known as Bob, points at the object previously known as Jane, and vice versa. So they still have one reference, even though they're now unreachable from the namespace. Then the pointers that we previously had are not in the global namespace anymore. So here's a visual representation of what happens here, because that's kind of abstract. First, we are creating these objects. We've got Jane and Bob, and they've got names. Then we cause them to point at each other by making them be friends with each other, just setting one attribute on one that points to the other and vice versa. Then, when we delete the pointers from the namespace, we've got rid of those pointers that allowed us to access these objects. But you can see that there are still those orange arrows there. There are still, each of them still has references. There's no connections from the namespace. This whole setup is isolated from the namespace. It is a cyclic isolate. So reference counting isn't sufficient. Reference counting cannot handle this situation, right? Where we've got objects that point to each other, but we can't get at them from the namespace. This is memory that is useless to us. But if Python only used reference counting to free memory, it would just stay there forever. And essentially you'd get sort of memory leaks. And eventually your interpreter would run out of memory and it would be a bad time. So what happens in this situation? This is where the garbage collector comes in. And we're going to be specifically looking at CPython's implementation of garbage collection. And what the garbage collector does is that it detects these cyclic isolate structures. It calls their finalizers, these del methods, these magic methods, and it breaks the cyclic references. And once the cyclic references have been broken, the objects within that cycle will have, that were in that cycle, their reference count will fall to 0, and reference counting can come and hoover them all up. So let's have a look at the garbage collector. We can actually just import it and have a look at it. It is a module, and the garbage collection, how it detects cyclic isolates is that it keeps track of all the objects in memory. Well, not quite all. It keeps track of all the objects in memory that could possibly form part of a cyclic isolate. Any object that has the capacity to contain a pointer could form part of a cyclic isolate. Strings don't have that capacity, and so the garbage collector doesn't track it, and you can see it by calling this method. Lists do. So if you check whether the garbage collector tracks a given object and that object is a list, it'll be true. And any user-defined class, this will also be true because we can define arbitrary attributes on them. So an instance of my name class is tracked by the garbage collector. And the garbage collector has this method called a traversal method that it can use to look at all of the things a given object points at. If I start with Jane, it can know that Jane's friend is Bob. And using this method, it can detect whether there are cyclic isolates, because it's quite easy using this to detect a cycle. Well, it is possible to detect a cycle of objects. And once it's detected a cycle, it's trivial to check whether or not there are any pointers in the namespace that point at that cycle. And here we can see that traversal method in action. It's called getReference. And if we call it on a list, we can see that that list points to 2 strings, which is exactly correct. That's its contents. So we're going to set up our cyclic isolate situation again. We've got Jane and Bob, they're friends with each other, and now we got rid of their names from the namespace. If we import the garbage collector, we can now fix this by manually triggering it to run its collection method. And if we do, we can see that it prints out those print statements from the magic del method that we looked at for, and it also prints us out a number. And this number refers to the number of objects that have been removed from memory. And you might think it was only 2. It was the 2 instances of our name class, but they also each had a name, a string name, and that's been removed too. So it's actually 4 objects. So that's how the garbage collector works. However, there is one way that this situation can go slightly sideways, and that is if you do something a little bit funky in your magic method del. Because what happens is when the garbage collector goes around and it calls the finalizer on all of the objects in a cycle, it then afterwards checks that the cycle is still isolated, because it is possible during the calling of all of those magic methods for the cycle to become not isolated anymore, and we're going to see that happen. So we've defined this class, my bad class, because we're doing bad things with magic methods. And again, it's got a name. But before we print out that statement that we've seen previously, we're going to create a global variable. And globals are a way of creating something in the namespace from within a method, essentially. So we're creating a global variable called person, and we're just setting that global pointer to point at the instance of the class that the del method is on. So what we're doing essentially here is we're reaching out into the namespace just before this object is about to be removed from memory. We're reaching out to the namespace and causing something to point at that object, therefore de-isolating it. And let's see what happens when we try and call garbage collection on this situation. We're going to do the same thing again of setting up this cyclic isolate, except with this bad class that does nasty things in its magic method. So again, we've got this cyclic isolate situation. We've deleted Jane, we've deleted Bob. Now, if we call the garbage collector, it goes around and it calls the finalizers, and that causes those print statements to be printed out. But at the end, the number that it gives us is 0. It didn't remove any objects from memory. And the reason for this is that in our global namespace, we can see that we have that person pointer, and it points at an instance of my bad class. So the garbage collector couldn't safely remove those objects from memory because there was a pointer in the namespace that allowed us to access them. So what happens if we take a look at this person object? We can look at its name, and its name is Bob, and its person's friend's name is Jane. So we still have a pointer to the Bob object, and we still have a pointer to the Jane object through person.friend. And this actually makes sense if we go back and look at what happened in the garbage collectors, the print statements. It printed out Bob's print statement second, and that is because and that means that Bob's finalizer was called second, and Bob was the object that was most recently set to be equal to person. So by calling the finalizers, the cyclic isolate was no longer isolated, and the garbage collector couldn't remember it from memory. How can we possibly get out of this situation? Now we've got this isolated system that we can never use the garbage collector to collect, right? That's not true, because there is a very important property of finalizers, which is that they can only be called once per object. So while these objects are still alive in memory, their finalizers can never be called again. And that means that all we need to do in order to fix this, visual representation of what happened here. My bad class, we created a new pointer in the namespace when its del method was called. As we can see, Jane is not in the globals. We can't reference our objects through their original names. All we need to do in order to fix this, is to remove that pointer from the global namespace, that person pointer, and call garbage collection again. And we can see all it does here is it prints us out the number. It doesn't give us those print statements again, because that finalizer, that magic del method, had already been called for both of those objects, and it can only be called once. But it did detect the cyclic isolate that is now isolated because we got rid of that person pointer, and it did delete all the objects, which is what prints us out that for the two objects and their names. Right, that wraps up this talk. It's been a whistle-stop tour, and I'm sorry that I rushed a little towards the end, but I realized I was running out of time. Yeah.
Hey Eli, thank you very much. Very nice presentation, very nice presentation style. So yeah, thank you so much for that. Let me see if we have already some questions. So calling everyone, if you have any questions, then just write it down in the chat or in the Q&A tool. So let me see. Pierre is asking, do you have any benchmarks or references about how performance is affected when doing garbage collection?
Oh, I don't. I think it will depend on, how often are you creating cyclic isolates, because that's the thing that garbage collection is for. So if you are typically creating a lot of those throughout whatever it is that you're doing in Python, then running garbage collection more frequently could help you deal with the sort of memory leaks that's kind of causing. So the garbage collector, I didn't include this in the talk, it runs it runs every now and then, and the every now and then is based on how often you are creating and deleting objects in memory. Because the more objects that you're creating and deleting, the higher chance it is that you're creating a cyclic isolate. And you can edit, you can alter how often the garbage collection runs with that GC module. You can set the various levels of sort of frequency. And it's kind of complicated how the garbage collection treats objects. There's a thing called generations, which kind of keep track of how old an object is. And it's all a bit sort of opaque and very heavy on the maths. The short answer is it will depend on your program as to how much running the garbage collection more frequently will affect your performance. So not really. I don't really have any benchmarks. It'll be something to investigate within your own program.
Fair enough, but it depends is always a good answer to every question. Actually,
unfortunately,
I hear it quite often.
Yeah.
Yeah. Are there any like, let's say, common mistakes or some things that you say, okay, these are definitely don't do that with?
Globals are always a bit risky. So essentially, there's the concept of Python of scope. So once for example, a method within a class object has a sort of limited scope, and things. Let's say I create a variable name within that function within that method. That variable name won't be accessible outside of that function, typically. Using the global keyword is a way to reach outside that scope and sort of do something that outside of what Python normally expects you to do, sort of. And so it's one of those situations where you probably need to be very sure that is what you mean to do, and that that's the reason why it's what is able to sort of break garbage collection. Is why there's that edge case. So be careful when using globals. In general, be careful when overriding the magic methods, because they deal with some kind of behavior in Python that you might expect not to be able to be changed. But you can, because Python is for adults and it lets you do really nasty things. So be careful when doing them.
Okay, thank you very much. Then on a personal note, like how did you end up in tech and basically doing what you do now?
Well, I was always good at maths, and so I went to university and I studied maths. And as part of my course, I did a little bit of programming. My university had us do a computing project in our second and third years, and I liked that. So when I started looking for jobs, I started looking for software jobs. And so I started out as a developer, and I've bounced around a couple of development and data engineering jobs. And now I've ended up as a developer advocate, which I really love, because I like helping people, I like talking to people, and I like teaching things, but I also like working with code. So it's it's kind of the perfect mix for me.
Okay, that makes sense, and happy that you enjoy it. I'm sure that at least I enjoy very much your presentation style. So I think.
Oh, thank you.
And there is a lot of thank yous from Oliver, from Marcos. Thanks, great talk. AC saying very nice and compact presentation. Thank you. Thanks, Eli. Thank you. Your explanation was very clear for me as a beginner. So
I'm glad to hear it.
That would be a plus or something like that.
Yes, I'm going to get an A in doing talks.
I'm not sure how the grade system works in the UK.
Yeah, we have A's. I think at least we did when I was doing exams, which I'm glad I never have to do exams again. But
yeah, me too. Perfect. So Eli, I think this was it with that session. I want to say again, big thank you. You have been a wonderful guest, and I hope to welcome you soon again at one of our other events.
Well, thank you so much for having me, and yeah, I would love to come back and be involved.
That would be very nice. And greetings to the cat.
Yes, I will pass them along. I'm sure she will appreciate.
Perfect. Then see you next time again, and have a nice day. And I hope that the weather in Cambridge will become better during the day.
All right. Thank you.
Perfect. Thanks. Bye-bye. So we are going in a very short break before we head to the last session of the day, where we will talk about APIs with Python. So stay tuned and see you again in around 15 to 20 minutes.
Have you found your dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.
Everything is being influenced by code written by developers.
At some point, you're going to wake up and say, what the hell am I doing?
It's hard to believe. It's the largest group I've ever been in front of, I think.
We develop the future.
Hello and welcome back. I'm Guido Schweter, who is a developer advocate for Cisco DevNet and joining us from Mumbai. So happy to have you here with us.
Hi, Sid. Thank you. And thank you for having me over.
Perfect. Would you like to give us a sneak preview of what we are going to learn from you today?
Sure. So, first of all, hello everyone who is joining. I'm Shweta Palande, and I'm a developer advocate at Cisco. Today, we'll be talking about developing APIs with Python. We'll be talking about what an API is on a very high level view if you're not aware of, and then we'll go through some of the Python modules which you can use to get working with APIs. And then we'll touch base on what a synchronous and asynchronous API is in case you're working on a project where you're making multiple API calls. And so we'll talk about what are the best ways to address those kinds of scenarios.
Very interesting. So I would say have a lot of fun. The stage is yours, and we'll see each other after the presentation again.
Awesome. Thank you. All right. So starting with the agenda, as I just walk you all through this, we will cover about what REST APIs are, and then some frameworks about for the REST APIs for Python, and then synchronous and asynchronous ways of working with APIs. And then at the end, I'll share some resources with you to take your journey a bit further with Cisco DevNet and also to get in touch with me. Okay, so starting with just an API, forget about REST, just an API, an application programming interface, what it is. So in a very high level overview, if I just wanted to explain this to a 5-year-old, I would say that an API is a way for two applications to just talk with each other, right? So just let's take an example over here where we have an application, let's say a taxi cab application. And if you know that usually taxi cab applications, they have certain maps embedded inside it to ensure that the user finds the location of the taxi cab and is routed to its destination, taking a look at its route. So let's say that there is one such taxi cab application which you have, and you want to import the Google Maps data into your API to support the maps which you are displaying. So in that case, here's where the APIs will come into use. So basically what happens is your application will ask the Google Maps for some data, and this will be done via REST API. And in response to your request, the Google Maps will get back to you with that map data, which you will eventually use in your web application. So thus, in general, APIs help the developers to create applications that benefit the end users. And the possibilities are endless because there is so much data right now. Everyone is trying to build products which are API centric or API first, which means that any features they build upon the product, they make sure that there is an API exposed to that so that the developers can use that API to build more and more features or customizable applications on top of it. So we talked about API. Now, what is a REST API? So REST API, you can say it's kind of like an abbreviation which stands for representational state transfer. And a representational state transfer is a form of a REST architectural style. And any API which conforms to these principles of the REST architecture style is known as a REST API. REST APIs communicate over HTTP or HTTPS protocols, and thus there's an interface for the applications to send and receive data between each other. So within REST APIs, if you see, let's take a generic HTTPS URL and then break down the components into what are the different parts. So the first one, HTTP or HTTPS, is the protocol. So this indicates whether it's a secure URL using HTTPS or just in plain HTTP1. And then you have your main URL. Now here I'm using, this is the one publicly available free API called as deck of cards, where new decks, shuffle decks, pick up a card from the shuffle deck of cards. So over here, if you see the blue portion of the request, which is called deckofcardsapi.com, that is known as the server or the host. That is a domain name. And this is the domain name that resolves to the IP and port of the server or the host which is providing the web service. Then if you get a little ahead, you'll see that the green color coded portion, that is known as a resource. So a resource is basically when you have to dig in deep inside to the file directories to or the path of a certain domain or a host name to get to your specific API endpoint. So over here, API/dex/news/shuffle is actually a path which is leading you to a new deck of cards which you want to shuffle. And then the red color coded line over here known as deck count, these are parameters. So most of the time parameters are optional, but sometimes they are not optional. And the way you can give parameters to, one of the ways you can give parameters to an API is by putting a question mark sign and then directly typing out whatever the parameters are and then equals to the value. So basically parameters are used to filter or make some more granular request if the API supports it. So REST APIs, as we discussed, they are based on HTTP protocol, and they support the CRUD operations, which is you can do create, read, or delete operations like post, get, put, patch, and delete. And then one of the most important parts, which I didn't want to miss out, but if you're talking about APIs, is about the headers. Now, headers are especially, let's say, if you are communicating with a server, the header information is something which is passed between the client and the server. All the APIs, they can have their custom headers, and it's included in both your REST request call and the response call. So let's say you're making a post request, which means that you are adding some data to a web form. So in that post request, there might be some header information which lets know the server that the body of the post is going to be of form application or JSON or application or XML. That is going to be the content type. Or it can say that the client can accept only application or JSON type of content from the server. It can have information about the authorization and other information such as date or timestamp. So these are, and when we, in the later part of the talk, when we look at some code samples, we'll see how to extract these header informations as well. So for now, this was a very brief high-level overview of what a REST API is. Now let's talk about some Python REST API frameworks. Okay. So first of all, let's see what a client library and API framework is. So if you see on screen right now, we have the request library, the PyCurl, and the Flask module. So request and PyCurl, these are Python client libraries for REST APIs, whereas Flask, it's an API framework. A client library is basically a set of API methods that enables sending HTTP requests to your endpoints, whereas a framework which contains libraries of codes and APIs from which you can draw information for your application. So take, for example, a web application. So a framework, it provides a set of libraries and tools to help the programmers to achieve their goals. So for example, if the goal of the programmer is to develop a web application, the framework will provide a set of libraries to ease the effort required to develop both the front end and the back end of the application. So thus the framework will actually abstract the complexities of achieving the operations of the web application, and would thus provide like a boilerplate code to make the programming logic more simpler. So with that, let's look into what a request library is. So basically, as I said, request is a client library, and it's a very popular HTTP client library in Python. Whenever we are dealing with with REST APIs and Python, chances are that we are using request module. So, and as the name suggests, it's used to make API requests, and it supports all the HTTP methods and advanced HTTP features such as authentication, session cookies, SSL handling, and more. So so this is just one code example. I'm using a VS Code editor to run my code over here. And this is a simple Python code demonstrating the request libraries. What you have to do is first import the request module. Request can be easily installed using pip install request in Python. And then we have also imported some JSON just to make the data in a more readable format. And then this is the base URL, or essentially this is the API endpoint to which we are going to be making all the requests. So this is right now running on a Flask web server in my local system. We'll also look at this Flask web server later on, but at this point, consider this as one of our endpoints. And then let's take a look at what a GET request looks like. So just going to expand this function, just created a definition called GET. And there is a simple one-line sentence, request.get, and which takes in a parameter called base URL. And the base URL is your API endpoint. And then we are storing that in the response, and this GET function is returning the response. So this is as simple as it gets. And then we just expand the main function, calling the get function first. And there's just a bunch of print statements to print the status code, the content of the get request in its normal format, and then converting it into JSON. And also we'll try to get its headers. So let's quickly run this. I can request.py. And you'll see that we receive the status code as 0. And then this is the response received when I did not convert it to JSON. So this is essentially in bytes format. And this is the JSON format data, especially it's cleaning up the content and displaying it in a nice readable format. And then these are the response headers which I received from my request. So we saw the GET request, and let's see what a POST request looks like. The POST request is almost similar. Instead of GET, we do a request.post syntax, and then you have to fill in arguments like the base URL, the data, which is the data which you want to post or send over to the server, and then the headers. So right now we just giving some very basic simple data which I've defined here in a dictionary format, and this data is just some numbers. And then the headers are again over here we are specifying that the headers is of content type application/JSON. And let me just uncomment this code right here. And when we run this script again, oops. Let's see. Didn't expect this. Expecting value line 1 and column. Okay. I know there was some minor mistake I did over here, and I don't want to waste much time in going through that. So if in the end there's more time, I'll get back to this again. But for now, let's move ahead on to the next module, which I wanted to talk about was PyCurl. So I have another code example right now to show about PyCurl. And that is this one right here. So basically PyCurl, it's a Python wrapper over the libcurl library, and it's used for multi-protocol file transfer. You can use it to fetch objects that are identified via URL from a Python program, or just like how you do with URL lib Python library. And it supports many internet protocols like HTTP, SMTP, FTP, and others. So if you're familiar with libcurl or ccurl library, you'll find it easy to use this Pythonic interface. So this is a Python code for PyCurl right over here, and you'll see that we are importing PyCurl. You'll have to do a pip install for PyCurl as well. And then we are also importing the bytes.io library, and then the URL lib.parse to encode the data. So again, this is the same base API URL which we are going to make requests to. And so in case of PyCurl, so we saw that in request, it was simply a one-liner, request.get and request.post to get and post API request. When it comes to PyCurl, the syntax might look a little bit more complex as request as compared to request. So basically, you will have to do first. You'll have to create an object of the PyCurl library. So we have done that using a variable called curl, and then you need to pass a URL using the syntax called set options, which will first take the URL, curl.url, comma, that is the tag, and then the value, which is the base URL. And when after calling the get request, you will have to do a curl.perform. So that's when the API will actually the call will actually get executed. So if we go back to the get request definition right over here, the first one thing which we are doing here is we are setting options again, and then using the header function to display the headers. So again, display header is again a separate function, which is nothing but a list of just trying to extract the value from the headers and making it more presentable. So this is what the whole display header function is doing. Nothing much, just trying to strip the name from the header, the value, putting that into lowercase, and then just appending it to a nice list. And then the other one over here, in order to write the bytes which we received from the content, we are going to use this function called write data, and then curl.write data, and then b object. This bytes object is actually the variable which we created from the bytes.io file right over here. And then once the get request, which we call this function, will do a curl.perform. So let's see how this works. PyCurl.py, and you can see that this is the output we got from our get request. This output is simply a hello world dictionary, which is how I had programmed in the Flask web server. And then these are the header values, again nicely parsed, put into lowercase, and then the response status code, which we defined as 200. Same when we go to the post request, we'll see that in case of post, there's an option called curl.postfields, which will take in the data or the body which you want to send over to the server. And then again, we also want to send headers. So there's another option called curl.http header, and then you pass in a list of your headers in the form of a list. And then again, we're calling the display header function to get a nice verbose reading of how the header looks like. All right, so if I run this function back again, you see there is, I think there's something wrong with my Flask web server, which is why the post requests are not going through. Let's see. Just quickly going to switch my Flask server to a RESTful one. And okay, there it is. Yeah. So as you can see, this is what we got as a post response. This was the whole body of my post response right here, along with the headers and along with the dummy data which we just posted gave to the server. And then these are the header values displayed nicely. And then this is the response status code 201, meaning that the request was successfully created on the server side. All right, so that was PyCurl. Now, PyCurl and request, as I said, are two client libraries, and usually if you want to create a web application or something, an application where you want to define your own API endpoints, you usually use the micro frameworks. And Flask is one of the most popular frameworks because it's easy to code and easy to understand. There are other frameworks like Django as well, but we'll begin with some simple and easy to understand frameworks like Flask. So going back over here, this is the very basic Flask framework which we can get started with in Python. What you have to do is basically start import Flask, and then I'm importing the request and the JSONify modules from it. And then you have to create an object right over here, instance of the Flask. So once that is done, let's say we want to create a get, we want to create a path or a route for an API which will serve the get request. So in that case, it's a simple method called hello world, which returns a simple dictionary known as hello world. And now this definition is decorated with app.root, and then you have to mention the root. So the root is basically your own Flask web server / whatever you write ahead of it will become the path or the endpoint to which your API will be served. So right here, we're just typing a /, and then this is going to serve as a get method. So, and then in the main function, we just have to do a app.run, and then it set the debug to true. So let's see. This is how it looks like if I'm running my basic Flask application right here. You can see that the debugger mode is on and the Flask app is running in the background. And because it's running on my local host, let's say I want to make a GET request to this application running right here. I'll just do a curl, make a curl request on HTTP. This is my local host and :5000, which the Flask is running, and hit enter. I'll see that I received my GET response, which I had configured. And also we'll see that the logs in my Flask app got updated with the event log. So this was a GET request, and let's see how you can do a you can do a little bit advanced GET request with it is by just let's say you want to do multiplication of any integer of any number which the client serves to you. So this is the I created a root called multi / and then I'm trying to define an integer column number, which means that it will take in any integer and then just simply multiply it with 10. So let's try this once again. This time I'll select my route as Perl HTTP localhost :5000. Now I'm going to go over this path, which is /multi and then / give any random number, let's say 49, and hit enter. It will return to me. It will return back to me a sum, a result of something which is multiplied by 10. So yeah. So this is this was the Flask, or you can say the vanilla flavor of Flask, which is available in Python. Now, and I really like Flask because it's a massively popular web framework in Python, and it's mostly used and well adapted for building web applications. And over the last few years, Flask has added a lot of features and updates, which almost makes it as good as a full stack framework. And it also has a minimalistic approach to building web apps, which you just saw that it's very easy to build routes around it, and thus it's a perfect choice, or I would say a preferred choice for developers. So now let's look at another extension of Flask, which is called a RESTful Flask. Now, a RESTful Flask It's an extension of Flask, which adds more support for quickly building REST APIs. And it's a very lightweight abstraction of it. So the Flask RESTful encourages more best practices with minimal setup. And if you're familiar with Flask, RESTful Flask should be very easy to pick up. So this is how the code for RESTful Flask looks like. We are importing. You also have to make sure that you install the RESTful Flask. RESTful Flask module in your environment. And then once you import that, uh, note that we are importing resource and API. These two are the more important parts introduced with RESTful Flask over here. So we are making the instance of the Flask class name like before. And now there is an additional instance known as API, which we are providing the value of our app. So right now, for the get and post request, let's say for the hello world, we're making a class called hello world, which takes in the resource, and the get function will essentially return to you hello world, and the post function will get some response and then just throw back that response back at you. And then there is another class which again does the same thing, does the multiplication and returns your number multiplied by 10. Now, if you see the difference between the Flask and the RESTful Flask over here is that at the end in RESTful Flask, we have added the resources separately. So what we have done is we have written api.addResource and then return the routes separately instead of putting them as a decorator on top of each of the definitions. So I've done this again for the multi-class and then provided my route and the number int number. And then at the end, it's just app.run, debug, and true. So this will show the exact same behavior as a normal Flask has done. But if you can see, let's say if you are dealing with a huge code base, RESTful Flask kinds of gives you a more cleaner looking appearance and I would say more modular structure if you're creating a very complex app. So definitely check out this one as well. All right. So we spoke about Flask and RESTful Flask. So we spoke about the frameworks for APIs. Now let's see what are synchronous and asynchronous ways of dealing with REST APIs. Okay. So let's take an example of you must be familiar with the term synchronous and asynchronous in programming. We'll touch base on how these two things work in terms of dealing with APIs. So let's take an analogy of a grocery store, right, or a market. If you go to a grocery store and you get some food item and you pay the money, as soon as you pay the money, you get the food item back. There is no delay in between that, right? On one hand you give the money, on the other hand you receive your food item. So that is what synchronous work would mean like. For asynchronous, imagine that you're in the grocery store and you give the money for a food item, but instead of the food item you receive a coupon for their food item. So you take that coupon and go and wait in the waiting area. And meanwhile, the other customers are doing the same thing. They're paying the money and they're instead getting coupons. And then whenever your food item is ready, you will be called upon and then you can get your food item and go back. So difference here was that in asynchronous, what happened was there was a certain kind of delay, or you can say you had to wait a little to get your things back. It didn't go in a very straightforward or linear fashion. So just like that, synchronous programming, the methods are returned to perform just one task at a time. So if a function depends on other functions' output, it has to wait to finish the execution of that function. This program is essentially stopped until the function finishes its execution. So this means that only one program can get executed at a single time. So let's start coding some examples of synchronous Python synchronous API. So I'm just going to quickly create a sync.py file. Okay. And let's start by importing the request module. And so what we'll do is, as we create the sync and async code, we will also make sure to time the code and see how much time it takes for execution of both. So in order to time the code, there is a timer function right here, which I've created. I'll get back to that function after a while, but for now, let me just import the timer function right now. From timer, import timer. Then I'm going to define my base URL, which is, so again, this is one publicly available base URL, which I'm just using. So nothing fancy. It's going to give me just print out the UUIDs. So once we get the URL, let's define a method to fetch the URL. So we'll define fetch, which will just going to take my base URL, and then we will use the sessions module from request because so what I'm going to do is I'm just going to make 100 requests again and again to the same URL instead of just getting 100 different request URLs. And in order to maintain that underlying TCP handshake connectivity, we're using the session so that the session is maintained. So with session dot get URL as a response, so let's just print the response dot JSON, and then I want the UUID part of it, so just point that out. Okay, and the fetch will also get a session variable. Now let's define function main, which now using the request.session as session. And then just will try to loop through the same request 100 times and then call fetch session and then my base URL. And okay, so we talked that we are going to time the execution of this code. So this is a timer script, which is essentially like a wrapper function using the timeIt module in Python. So timeIt module, it's an excellent tool for measuring execution of code snippets, which are small, and it gets a very accurate results. So over here, we're using the timeIt.repeat function, which gives the function which you want to execute, then the number of times you want the request to go, and then the repeat here is it's essentially how many times you want to time the execution, calculate the execution time of your function. And then in order to calculate the time, what I'm going to do is just print out the sum of all the runs and then divide it by the length just to get the time, and then return the wrapper. So right now in our sync, what we'll do is decorate our main function with timer, and just going to pass 1 and 1 to it. Okay. So my Flask app is running in the background, and let's see what we get from this. sync.py. Okay, it's printing out all the UUIDs. So since we are running it 100 times, it's going to loop all those 100 lines of UUIDs. And then we'll see how this compares to the async request. Okay, so here is it. We see that we were able to access the 100 URLs in 23.72 seconds. All right. Okay, so keep this number in mind. We will come back again with when we do the async library code. But right now, let's move ahead with some other tools. So, okay, we talked about synchronous, and we saw that how synchronous was completing only one, performing only one task at a time. Now, there are other ways in which you can perform multiple tasks at a time. And and some of these ways are multiprocessing, multi-threading, right? So I'll just scratch some surface on what multiprocessing is. Now, multiprocessing, let's say that you went to a restaurant and where there are two chefs, and there is a second customer which comes after you, and he orders food and you order food. And so when both of you order food, you both are likely to get the food prepared at the same time, because there's one chef preparing your food and the other one working on the other customer's food. So that is what multiprocessing in high level is about, right? It's when both the tasks run in parallel and they are not concurrent to each other. And so multiprocessing, it's, you can say, achieves parallelism in its truest form, because they run across multiple CPUs. So in order to do multiprocessing, first of all, you have to have multiple CPUs. And these multiple CPUs, when they are running multiprocessing on them, they do not share the resources among them. Each processes can have as many threads as they want running in its own memory space. So in Python, multiprocessing is done by importing the multiprocessing module. So that was multiprocessing. And for multi-threading, again, consider that again you're going into a restaurant, but now instead of two chefs, there's only one chef. And when you order a meal, the chef will start preparing your order. And when another customer comes, he will start preparing his order until your order is maybe in the oven or maybe it's getting marinated. So he might not guarantee that your dish will be prepared first before the second customer, right? Because it depends on the chef and on the priority he decides. So likewise, multi-threading is a technique where multiple threads are spawned by a process to do different tasks and about the same time, just one after the other. So this gives you the illusion that the threads are running in parallel, but they are actually running in a concurrent manner. So in Python, we have the GIL, or the global interpreter lock, which prevents the threads from running simultaneously. So again, you can in Python, you can implement multi-threading using the thread pool options. But yeah, apart from multi-threading and multiprocessing, we can move ahead and see what the asynchronous ways of dealing with APIs are. So asynchronous programming has gained a lot of attention in the last few years, and for good reason. Like although it can be challenging than the traditional linear style, as we saw just right now in case of synchronous, asynchronous method is much more efficient. So for example, instead of waiting for an HTTP request to finish before continuing the execution, the Python asynchronous async coroutines, you can submit the request and do other work, which is waiting in a queue just while you're waiting for your HTTP request to finish. So async IO is just like multi-threading. It also does context switching to support concurrency, but it's a bit different than multi-threading in two ways. The first one is that it uses a single thread, as you can see here in this figure. And secondly, it's your code which decides when to leave control of their own thread, so that some other portion of your code can run during the meantime, which is unlike multi-threading, where it's done preemptively by the library itself. So as you can see here, there's just a single thread, and let's say the green block is where you are trying to make an API request to download a file from the browser. Now, as the file is being downloaded, or as the request is being made to the server, and when your code is waiting there, sitting for the server to reply back, what he'll do is he'll utilize that time to do some other work, like this red block where it's trying to calculate or do some mathematical computations in the background. And as soon as he receives that API request or a response from the server back again, he'll switch again back to the previous task. So this is what in a single thread, in terms of context switching, the async IO is working. But while implementing this, sometimes there can be problems. So for example, let's say there is a third-party library that you're using to interact, and that client is blocking in nature. That is, it runs synchronously. So for example, the request module that you're using for making HTTP request, that's blocking in nature, right? And that is synchronous. So the complete process of making the HTTP request effectively becomes synchronous, even if you are using async IO in your code. So what's the solution for that? The solution here is a Python module called AIO HTTP. So AIO HTTP, it's asynchronous HTTP client server framework for Python. And it basically knows when to make the HTTP request and just stop and let async IO run anything else during the meantime when the HTTP response is being waited. So AIO HTTP helps you in doing that. So we'll look at that code base again right here. And what we will do is we are going to replace the request library with AIO HTTP and then do some minor changes to our existing code here. And then let's see if async IO is able to run our code faster or not. Okay. Just create a new file called async.p1. Okay. And what we'll do is let's just copy paste this whole code as it is and then make some corrections to it. So I'm just copying my synchronous code right here in async IO. And then first step, let's get rid of request and install, just import async IO library. And it's also, we are going to install the AIO HTTP library. Okay. Let's keep the base URL same. Now, with now what we want to do is we want to again fetch our URL. So with async IO, what we have to do is start the method with the keyword async. So it will be async and then the definition fetch, which will receive our session and the URL. And then we are again with session.getURL as response. What we want to do is, so we are going to make 100 requests to the same URL again and again. And once the server, a client is waiting for the server to come back with the request, we are going to mention that await keyword to wait till the server is going to come back with the request, and then in that time execute another API request. So instead of this, let's create a variable called JSON response. And by the way, if you haven't noticed, I keep on getting this auto code complete suggestions in my VS Code. And that is because I'm using a Tab 9 software. So it's right here. It's a Tab 9. It's a plugin for VS Code over here, right? So it's a plugin for VS Code. Basically, it has plugins for other IDEs, I believe, as well. And Tab 9 is like an auto code complete solution. So it works on ML and it keeps on learning your code repositories and your coding style and all the things which you have been doing in your same repository wherever you have that plugin installed. And because I've been using Tab 9 for a lot of time, it gives me pretty accurate code complete autocomplete results, even for not just for Python files, but when I'm working with Markdown files and there's a lot of written content, it gives me some really intelligent autocomplete suggestions over there as well. So we can check that out. But coming back with the code, I have JSON response, and then I'm going to paste the keyword await and then response.json, because I want my response to wait till the other request, the server doesn't come back that, okay, this is what your response is. And then we'll just print out, again, the JSON response with what we want was the UUID. Okay. It's going to, let's define this later, but as of now, let's make our main function as asynchronous as well. And then with the, so right now what we want is a client session. So I'm going to type async with AIO HTTP dot client session with this as session. Now let's create an array of the tasks which we want to complete or achieve, and so that would be our fetch function takes in session and URL for this in range of 100. And then we are going to again place a keyword await and async io dot gather. This is where we are going to gather all our asynchronous functions, and then I'm going to pass the arguments of my task. This is going to be my base URL. Okay, and now let's create our timer function. So basically, definition which runs my async io.run. Then I'm going to run it to the main function, and then to assign a timer to this, it's 1,1. Okay. There should be, I guess we'll come across some errors over here. Let's see what the errors are. You can debug that. Okay, syntax error. Fetch session. Async. Okay. Just going to quickly rewrite that in case I missed anything. task, it's an array, and then I want to fetch my session, comma, base URL. Range 100. Okay. Save this. And okay, it says attribute enter. Yeah, I forgot that we also have to introduce this keyword called async with. So, right, we mentioned it here. We didn't mention it in the fetch function. And again, if we run the code, okay, we see that, wow, this was so fast and actually gave out the URLs back in 2.27 seconds. So that is a really good performance. Okay. All right. So yeah, so as you can see, while we were doing the synchronous programming, we got our 100 URL API request in 23 seconds or something. And this right here, using AIO HTTP, we got it in 2.27 seconds, which is really awesome. So we can see how you can save the time in case you're dealing with multiple or you're heavy lifting with the APIs. So that was all about APIs and then using different Python modules to go through the APIs. If you're a beginner with Python coding, or if you are a beginner with REST APIs and you want to explore more learning labs, you can go on to Cisco's developer program. And if you are also looking for some code samples or maybe any automation samples to build more applications using your existing tools, you can also check out our automation exchange or code exchange repositories in DevNet. There are tons of resources right over there. You just have to go and navigate the website and see what fits you best. So don't forget, this is our website, developer.cisco.com. You can go there and explore our tracks and our upcoming hackathons or events and seminars. And along with that, if you have got many more questions, feel free to follow me on Twitter or send me a quick email on this email ID right over here. You can also follow us on Cisco DevNet. We're on Facebook, GitHub, LinkedIn, everywhere. And it's also some of the developer blogs which me and my fellow dev advocates write as well. So with that, I'm happy to take any questions or happy to discuss anything, your Start Now journey, or see if there are any interesting cool projects you're working right now using Python or using APIs.
Hey, Shweta, thank you very much for this overview. We have a couple of questions. We're running a bit out of time, but let's go over them. So it's anyways the last session, I think we can take them. First of all, Bjarne is actually wondering if McDonald's is multi-processing or multi-threading.
McDonald's, that's a good question. And by McDonald's, does he? So I'm not familiar with that library. It's just by hearing McDonald's, I'm thinking about
He means
burger
the
chain.
burger chain, because everyone lines up, then you have the cashier. And when you were discussing microprocessing, then he said multi-processing is like McDonald's, and then you basically presented multi-threading, and then he maybe is changing his mind. Maybe it's more like multi-threading. But so maybe someone can resolve that.
Yeah, well, that's a good question. I've been fortunate enough that the McDonald's which I've been through don't have much of queue, and so it's immediately like give and take. I don't have to wait for my order. But if there is a token system, I would certainly say multi-threading.
Perfect. But basically, while talking about that, like Ada was asking, what are some rules of thumb when to choose what? I think it relates like, async, sync, multi-threading, multiprocessing, and
Yeah.
so on. Like,
That's a very good question. And when it comes to selecting which one should I choose or select for my application or my project, it largely depends on first what your system in which you are building your application is built up of. So for example, if you have a single core processor or single CPU, you cannot do multiprocessing. In order to do multiprocessing, you need multiple processors, right? So that's gone over there. It also depends on your server which is going to with which you are going to interact with. If it's a server which you think or your web application which you think that is not going to make API request every second, but rather it's going to wait for 10 minutes and then just keep on doing that at a paced interval of time. So you really don't have to think about multi-threading or processing. But yeah, asynchronous IO, async IO would be a good fit, because then if other than just getting response from the APIs, if you're also doing some other stuff like mathematical or statistical stuff which is going on in your code. So yeah, there are a lot of things, and I think it's just sometimes it's trial and error which makes you realize that this is the best approach for my project.
okay, thanks. Then next question from Stuven. I hope I pronounced it right. Thanks for the hint. What other plugins do you use? And like, I think it relates to your VS Code plugins. So he's thanking you for tab 9 for the hint. But like any other plugins that you love, or some favorite plugins you use?
Yeah, sure. So yeah, tab 9, as I mentioned, it's really one of my favorites, and because I've been using it for a while, it actually I would say created a nice map or a nice machine learning program of all my coding, the way I code, or the functions which I use frequently, and then it kind of auto completes my whole thing. The other cool plugin which I like and I'm currently using is called Acrolinks. So Acrolinks, let me see if I can show you right here. Okay, so right here, Acrolinks, it's spelled like this, and it's also an AI-powered platform. Which it's so if you're familiar with what Grammarly is, we use Grammarly for correcting our content or email or anything like that. So Acrolinks is something which you do for your technical writing documentation. So I create, as a part of my role, I create a lot of learning labs and tutorials which are very heavily technically focused. And Acrolinks helps me a lot by giving me a score of how my overall content is looking in terms of grammar, indentation, or any specific, you can see, abbreviations or anything. And it has the power to customize your own project. So let's say you're working on a new project, and you can pre-fill or set up some parameters within Acrolinks, so that it can keep a check that if these all are being taken care of or not in your code.
Yeah, that's interesting. Cool. Good to know. And then let me see, what else do we have? Yeah, Lena is asking, are you familiar with human curl? And what's the difference to PyCurl, if you know about that?
Human curl. Huh. I haven't heard about human curl. I thought it was more about just the, I don't know if she's referring to the curl which we just do on command line.
From the timing
interface.
error, it was when you were presenting about PyCurl and giving the examples.
Yeah, that's a good question. I can look that up, and maybe if she can reach out to me, we can connect on what the human curl is. But I haven't heard about it.
Okay. And then last question, there is a question about error handling for the requests, like some best practices or some code snippets is written here. But
yeah, error handling from request library, or in general, just for Python, I would say try catch. Start with try catch exception handling, and then request also has a bunch of error handling methods assigned to it. It can start with the basic status codes and then get a more verbose reading about what went wrong, and then derive more insights based on the status codes. And the Python documentation for request is really nice and very detailed. So we can skim through that and see, whatever fits your own need and what you're looking for.
Okay, thank you very much. That was already the last question. So thank you so much for joining us. I wish you a nice rest of the day, Shweta, and hope to see you soon at another event again. So
Thank you so much for having me. Yeah.
Thanks.
Thank
and
you,
bye.
everyone. Bye. Have a nice day.
Okay, so this was the last session of this Python mini conference, but we are heading actually next week to our next edition of WeAreDevelopers Live. This time it's gonna be about Angular. So all the Angular developers or who are interested in that, make sure to join us next week again. And before we close this stream, just a quick reminder, if you haven't checked it out yet, visit WeAreDevelopers.com for interesting jobs in the European tech market. Also, a lot of them with upfront salary information, so maybe there is something in for you as well. And also, check out worldcongress.dev for our next WeAreDevelopers World Congress taking place in Berlin this summer with around 5,000 developers from all around the world and more than 200 speakers. It will be an amazing event and you shouldn't miss that. With all of that said, have a nice rest of the day and see you next time again. Bye-bye.
Everything is being influenced by code written by developers.
At some point, you're going to wake up and say, what the hell am I doing?
It's hard to believe. It's the largest group I've ever been in front of, I think.
We develop the future.